So, have you ever really thought about what's going on under the hood when you make a Bitcoin payment? On the surface, it seems so simple, right? But just beneath that, there's this whole hidden world, a really fascinating system that's actually designed to protect you. Let's dive in.
Let's kick things off with a simple question. Say you've got some Bitcoin. You spend a little bit of it. What happens to the rest? Where does that leftover amount actually go? The answer to this question, well, it pulls back the curtain on a core and honestly, pretty clever feature of how Bitcoin works.
To get our heads around this, we need to talk about what's sometimes called Bitcoin's cash problem. And the short version is this: you just can't break a digital bill.
Okay, here's the fundamental rule you gotta know. Every little chunk of Bitcoin you own is an input. The technical term is a UTXO. And when you decide to spend one of these inputs, you have to spend the entire thing. You can't just tear off a corner. This one rule is what makes Bitcoin act way more like physical cash than your typical digital bank account. Just think of it like this. You're buying a $5 coffee with a $20 bill. You obviously expect to get $15 back in change. Bitcoin works the exact same way. If you have, say, a 20 Bitcoin bill and you need to pay someone 5 Bitcoin, you can't just send 5. Nope, you have to hand over the whole 20, and the system is designed to make sure you get 15 Bitcoin back as change.
All right, so if you have to spend the whole amount every single time, how in the world do you get your change? Well, the Bitcoin network has this really elegant solution. Let's look at how your wallet actually pays you back.
This solution even has a name. It's called a change output. And yeah, it is exactly what it sounds like. When you create a transaction, your wallet is smart enough to also create an extra output whose only job is to send that leftover, unspent portion of your Bitcoin right back to you. Here's how it plays out in 3 simple steps. First, your wallet grabs that 20 Bitcoin input. Then, it creates a transaction with 2 destinations. One output sends the 5 Bitcoin to the person you're actually paying, and that second output, the change output, sends the remaining 15 Bitcoin right back to an address that you control. It's a clean and super effective system.
And this is where things get really interesting. From the outside, to anyone looking at the public blockchain, that payment you made and the change you got back look identical. The protocol doesn't put a little label on them saying, hey, this is the payment, this is the change. They're just 2 outputs from a single transaction. This detail is a very, very big deal, and we'll come back to why in a second.
So we know what a change output is, but that just opens up a new question, doesn't it? How does your wallet decide which of your Bitcoin bills to use for a payment in the first place? This is where we get into what's known as the art of coin selection. I mean, think about it. Your wallet might hold dozens of these little inputs from past transactions, some big ones, some tiny ones. When you hit that send button, your wallet has to make a strategic choice about which of those pieces to bundle together to make the payment. So, how does it do that?
This whole strategic process is called coin selection. You can think of it as the brain inside your wallet, the little algorithm that's managing your digital cash. It's constantly making decisions, trying to optimize for things like cost and, you guessed it, privacy.
The absolute best way to understand this is to go right back to thinking about the cash in your physical pocket. We all do this subconsciously. When you open your wallet to pay for something, you're performing your very own version of coin selection.
For instance, are you a spender? The person who always grabs their largest bill, pays, and then gets a bunch of smaller bills and coins back as change. The result is your wallet just fills up with all this loose change. Or maybe you're a consolidator. You're the one who always tries to pay with exact change, gathering up all your small coins just to get rid of them. You might end up with only big bills left in the end.
Most of us naturally find a balance between these 2 extremes, and that is exactly what Bitcoin wallet developers try to program into their software. They create these really sophisticated coin selection strategies that aim for that perfect balance, managing your inputs efficiently so you don't get a wallet full of digital dust, but also not leaving you with only huge bills that you can't easily spend. Okay, so we've seen how Bitcoin deals with inputs, with change, and even selection strategies. But why? Why go through all this trouble? Why not just have a simple account balance? Well, the answer, the whole point of this entire system, is all about privacy.
Let's connect all the dots here. First, we know transactions create change. Second, and this is the absolute key, your wallet sends that change to a brand new address that you control, not the original one. And third, this is not a bug. It's not a glitch. It is a deliberate and absolutely critical privacy feature.
And here is the big payoff. Remember how the protocol can't tell the difference between a payment and your change? Well, by making them look identical and by sending the change to a fresh, never-before-seen address, Your wallet creates confusion. It prevents address reuse, which makes it so much harder for some outside observer to link all your past and future transactions together. They can't be sure which output went to the merchant and which one came back to you, and that significantly obscures your financial history.
So the next time you send a Bitcoin transaction, just remember all of that invisible work your wallet is doing. It's not just sending money, it's acting as your own private financial strategist. Which kind of leaves us with a final thought. If your wallet is automatically managing your change just for privacy, what other hidden features are quietly working in the background to protect you?